In topic 9.3, we're going to be talking about the greenhouse effect, which relates to the science behind why certain gases lead to a warming planet. And so the greenhouse effect is a scientific phenomenon in which certain gases that are in the atmosphere capture infrared radiation that the Earth is radiating, and that leads to the warming of the Earth. So if we look at the phenomenon of incoming solar radiation entering the Earth from the sun, in that incoming solar radiation, the atmosphere allows much of it to pass through, reaching the Earth's surface. As the Earth absorbs that energy, it eventually re-radiates it out to space as infrared radiation. But gases in the atmosphere capture some of that re-radiated infrared radiation and keep it closer to the surface of the Earth, resulting in warming. And this greenhouse effect is really important. It actually makes life on Earth as we know it possible. If there were no such thing as the greenhouse effect, the average temperature of the Earth's surface would be something like 0 degrees Fahrenheit, very cold. But the average temperature is actually around 59 degrees Fahrenheit. And so these greenhouse gases that are present in the Earth's atmosphere naturally tend to warm the Earth. The problem is that when humans release excess greenhouse gas into the atmosphere, it sort of acts as like piling blankets on a bed, trapping more and more heat close to the Earth's surface. And that results in the overall warming of the Earth, and that results in climate change. The main gases that we refer to when we're talking about greenhouse gases are carbon dioxide, methane, water vapor, nitrous oxide, and also different types of fluorocarbons. And we can see this table in the lower left-hand corner. When scientists are talking about greenhouse gases, such as carbon dioxide or methane, etc., they try to equate them as to how much warming they can cause. They do that using this concept of the global warming potential, GWP. So for the global warming potential, carbon dioxide is used sort of as the baseline gas. So one molecule of carbon dioxide released in the atmosphere results in a certain amount of warming. And that's set to a standard of 1 as GWP. If you look at methane for an example, methane has a GWP of 21. What that means is each atom of methane heats the Earth 21 times more than a molecule of carbon dioxide. Nitrous oxide has a global warming potential of 310. So a molecule of nitrous oxide, N2O, results in 300 or more times the warming that carbon dioxide molecule would. So we equilibrate, maybe I just made that word up, all of these different gases to carbon dioxide to help us compare their impact on climate. Some of these gases, especially the fluorocarbons we can see here, have GWPs in the thousands or even tens of thousands. So these gases, hydrofluorocarbons, which were used as an alternative to ozone depleting substances, can warm a molecule of these HFCs contributes more than 10,000 molecules of carbon dioxide. The chart also shows some detail about the sources of these greenhouse gases. Okay, carbon dioxide comes from the burning of fossil fuels, also changes to land use related to agriculture and deforestation. Production of cement is also a big contributor of carbon dioxide to the atmosphere. Methane comes about by fossil fuel use, natural gas, leaks of that natural gas, as well as agriculture, especially cattle agriculture. Those result in methane release. Nitrous oxide comes from mostly agricultural sources, using fertilizers. And then the fluorocarbons generally come from ozone depleting substances. They are an alternative. So we talked about ozone depletion, and some of these hydrofluorocarbons were used as a substitute for chlorofluorocarbons, which helps reduce the impact of ozone depletion. But these are intense greenhouse gases, so they then produce this problem of climate change. And then you can see some other sources of these other types of anthropogenic gases here. We also see that different gases last for different amounts of time in the atmosphere. For example, methane is relatively short-lived, that it decomposes in a matter of a decade or so, a little more, whereas carbon dioxide lasts longer in the atmosphere, nitrous oxide even 120 years, and some of these other chemicals can last thousands of years, tens of thousands even. Now, water is a greenhouse gas, but it moves into and out of the atmosphere very quickly. It cycles rapidly, so we generally don't consider water vapor as we're talking about anthropogenic climate change.